So, good morning, everyone, and welcome to this brand new lecture. In the previous class, I think, do we remember what we did in the previous class? We had covered the concept of collision, and we had seen what happens in an elastic collision, perfectly in an elastic collision, and we are expecting not questions but not numerical problems, but mostly theoretical problems from that part. Similarly, in rigid bodies, or people call it rotation, we again expect very few numericals, and most of the questions would be theoretical in nature. So we will try to cover them as well. Rigid bodies or rotation. Now, first of all, since the name of the chapter is rigid body, we have to understand what is a rigid body. Can anyone tell me what is a rigid body? The meaning is hidden in the name itself. Rigid body. What do you mean by a rigid body? Anyone? Anyone knows what is a rigid body? So, in very simple terms, a rigid body is nothing but a collection of particles. There can be almost infinite number of particles in which the distance between each pair or any two particles remain constant. So, whenever we have a system of particles such that any two particles you take and the distance between any two particles remain same, then the body is known as a rigid body. There is no change in the size or the shape of a rigid body if any force is applied. Such a body is known as a rigid body. Now, you must understand that this is completely a theoretical concept. Now, this body or any body that you see, I'm applying a force here. I'm holding this body, I'm applying this force here. Now, it may look like nothing has changed. There is no change in size and shape of this body. But trust me, when I've applied force, some changes have taken place at the molecular level which we are not able to see. Some changes has taken place. Some molecules may have shifted here and there very slightly. It, it does not look to us on the naked eye, but some changes may have taken place. If I apply a force on this body, no matter how small or how big my force is, it has caused some change in its size and shape. We may not be able to see it. So basically, what we have to understand is it's a theoretical concept or a mathematical concept, and that is what it is given here. It's a mathematical concept. It may not actually exist, but in this chapter, we are going to imagine that all the bodies that we are going to deal with are going to be rigid bodies. When we say they are going to be rigid bodies, that means whenever we are going to apply force on those bodies, their shape, size, or distance between the particles, any two particles, the distance between the any two particles will not change. When I say distance between any two particles, what do I mean by this? Suppose this is a body of a random shape, and there are there is particle A, there is a particle B, there is a particle C, and so on. Now, whatever I do on this body, whatever force I apply on this body, the distance between B and C, the distance between A and B, and the distance between A and C never changes. If it never changes, that means the shape and size of the body is never going to change. That body becomes a rigid body. So this distance between A and B should remain same always. This distance between B and C should remain same always. This distance between A and C should remain same. I just take an example of three particles. There could be infinite number of particles in this body. If the distance between any two pair, any random pair remains same, then the body is said to be a rigid body. Do we understand this concept of rigid body? Yes or no? I'll give you 2 minutes to note this down. Let me know once you are done. Well, then we move on. Basically, it is rigid body dynamics. We are supposed to understand the motion of a rigid body. Now, when we talk about a rigid body is a collection of large number of particles. There are three types of motion of the rigid body that we'll have to understand. The first one is known as pure translation. The second one is known as pure rotational, and the third one is the combined translational and rotational, which is obviously the most difficult one. So there are three types of motion of a rigid body that we will have to understand. We will go through each motion step by step. Please note this down first. We'll go to each and every motion step by step. I'll give you 2 minutes to note down these three types of motion. We have these three types of motion of this rigid body, and we have done a couple of these motions already. May not be a couple of one, but at least the first one we have already done. Now, what is the first type of motion? The first type of motion is known as pure translation. Now, what do you mean by pure translation? So write the heading, pure translation. Pure translation. Now, what do you mean by pure translation motion? Now, up till now, what we were doing in all these chapters, whenever we had a body, whether it was a bus or a car or a train or a man, even though it was a big body, we used to draw it as a point, and we used to say, okay, the man is moving like this, the bus is moving like this, the train is moving like this, the plane is moving like this, the body is moving like this. So basically, instead of taking the size and shape of the body into the picture, we were just telling you, we're just assuming that there is only a point and that point is moving. Why we were taking the entire body as one point? Because all the particles of that body were moving, were having the same displacement. For example, you see this phone. This phone is moving here like this. Now, if you take any point on this phone, or for example, this pen, if this pen is moving like this, or like this, or like this, you take any point on this pen, any point on this pen will have the same displacement, same velocity, and same acceleration. Do we understand what I'm saying? This type of motion where all particles or any particle has the same velocity, same displacement, and same acceleration, such type of motion is known as pure translation. Pure translation motion is a motion where you have all the particles moving with the same velocity, same displacement, and they have the same acceleration. Such motion is known as pure translational motion, and this is the motion that we were studying up till now. Up till now, whatever motion we were studying was pure translation. You can see this body. Can you see this body here? This body is at position A, and after some time it moves to position B. Now you can see every particle of this body has moved with the same velocity, it has the same displacement, and it has the same acceleration. Acceleration of all the particles, displacement of all the particles is same. Do we understand this? Do we understand this, everyone? So this type of motion, my dear friends, is known as your translation, pure translation. Acceleration of the point A or 1 is same as 2, is same as 3, is same as any particle. We can call it as A, simply A. The velocity of the first particle is same as the second, as same as the third. You can call it as V. All the particles have the same velocity, same acceleration. Do we understand this? Yes or no? Now, if you apply an external force on this body will have acceleration, and you can simply write F is equal to ma for this body, where m becomes the total mass of this body and a becomes the total acceleration. You can call it translational acceleration, call it anything. The complete body, the complete body, the complete body is moving as one unit. The complete body is moving as one unit. Such type of motion of a body is known as pure translation. Do we understand this? Yes or no? No or yes? Similarly, if you want to find the momentum of this body or momentum of this system P, you just take the total mass m and multiply it by that velocity. So you get the total momentum of this body as well. Do we understand this? Yes or no? No or yes? Similarly, if you want to find out the kinetic energy of this body, the kinetic energy of this body will be equal to half into total mass into V square. Remember here, M stands for the total mass of the body. Everyone understands this? I'll give you 2 minutes to note it down. Once you are done, please let me know. We move ahead. This was pure translation. This was pure translation. What is the second type of motion? Yes. What is the second type of motion? Of
Pure
a
rotational motion.
pure rotational motion or pure rotation, and we are going to concentrate on this one. But first, let us try to understand what is meant by pure rotation. So write the next heading, pure rotation. Pure rotation. Now, before going on to pure rotation, we have already written the heading, I guess. Let us start with an example of pure rotation, and probably that will make our life a lot easier. It's easier to understand in terms of an example. We have not discussed the definition of pure rotation, I know that. But can you tell me any example of a pure rotational motion? We have not discussed anything about pure rotation. But I know that you know what is pure rotation. And I just want to use that knowledge. without knowing anything. Let's not get into the complicated definition of rotation. What is pure rotation? Can you just give me an example of something that you see is in pure rotational motion with your own common experience, with your own common knowledge, common sense? Yes. Do you see anything around you moving in a pure rotational motion that you call pure rotational? Yes. No idea.
Earth revolving around sun, sir.
Earth revolving around sun. No, that is not an example of pure rotation. But if you change it somehow and not call it revolution of Earth around the sun, you think about something else that Earth is doing, that is pure rotation. Think, look at the things around you. You see pure rotational motion every day. In every room that you sit, you see pure rotational motion. Every room that you are sitting right now, you can see pure rotational. The only thing is it is cold. That's why you don't see that pure rotation. Yes,
Fan, sir.
fan, sir. Yes, sir. Fan. The motion of the fan. When you switch on your fan, my dear friends, the motion of the fan is pure rotation. The motion of the fan is pure rotation. Now we are picking. Can anyone give me any other example of pure rotation? Motion of the fan is pure rotation. Yes. Anything else? Pure rotation. Someone said me. Someone told me that the motion of Earth around the sun is pure rotation. No, that is not pure rotation. But something else that Earth does is pure rotation. What is that? Hmm. Something else. Rotation of Earth on its own axis that causes day and night. That is pure rotation. Because when I say it rotation. Rotation of Earth on its own axis. Earth is spinning, dung 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 like this. The spinning of Earth on its own axis is pure rotation. Anything else? Then we will try to understand the definition. Anything else that you can give an example for? Pure rotational motion, you see it every day, 24 hours. I'm going to see it now. Pure rotation. The motion of your seconds clock, seconds hand is pure rotation. Similarly, your motion of minute hand is pure rotation. Hour hand, it is very slow, but it is pure rotation. All these are examples of pure rotational motion. Do we understand? Examples of pure rotation motion. Why did I start with the examples? Because now once you understand the example, the concept may look a lot easier. Now, whenever we saw an example, we saw something very similar happening, something similar to what we have already done in the previous classes. Looking at the motion of the fan or looking at the motion of the clock, I mean the minute or the hour hand of the clock, it must remind you of something that we have already done. Does it remind you this pure rotation? Does it remind you of something else that we have already done? Does this pure rotation remind you of something that we have already done previously? No, it does not remind you of something that we have done previously. Some motion that we have studied previously. It does not remind you of that. Okay, not a problem. It does not remind you of this. I will try to make you understand. When you talk about the rotation of a fan and you look at all the particles of this fan, all these particles of the fan are moving in what type of motion? All the particles on this fan are moving with what type? What type of motion? Mhm. I'll give you the example of that ceiling fan. This is the ceiling fan. This is the ceiling fan and this is how it rotates. You take any point on the ceiling fan, any point P on the ceiling fan, and you look at the motion of this point. How does this point move? It moves in a circular path. And that is how you can understand. That is how you can understand pure rotational motion. So you can understand pure rotational motion in terms of our old counterpart, our old friend, circular motion. If a body is moving in such a way that all particles are moving on a circular path, or you can say they are moving in circular motion. Do we understand this? All particles are moving on a circular path or they are moving in circular motion. The centers of all circles lie on a line. The center of all these circles lie on one line. Can you see that line here in this diagram? Can you see this line on which the center of all these circles are going to lie? And that line is known as the axis of rotation. So all the points are going to move. First, listen to me, then I will give you time to write. Don't just keep on writing because I realized that your more concentration is on noting down everything and very less of the concentration is on understanding it. I'll give you time to write. First listen and understand it. So all particles are moving in a circular path, circular motion. The center of all these circles lie on one line. That line is known as axis of rotation. Do we understand this? The next point is omega. Let me not write. Let me start it as angular displacement. Angular displacement, omega and alpha is same for all particles. Just first understand it and then I will give you time to write. So all the particles are moving in circles. They have the same displacement, angular displacement. So if one particle turns by 30 degrees, all the particles will turn by 30 degrees. So it is similar to translational motion. In translational motion, what was happening? If one particle was moving by 5 meters, all the particles were moving by 5 meters. Do we understand this? When in pure translation motion, if one particle moves by 5 meters, all the particles move by 5 meters. We understand this? In pure rotation, if one particle rotates by 30 degrees, all the particles rotate by 30 degrees. This is pure rotation. So this is pure rotation. If one particle rotates by 30 degrees, all the particles will rotate by 30 degrees. All the particles will rotate with the same angular velocity. All the particles will rotate with the same angular acceleration. Do you remember omega and alpha? Angular velocity, angular acceleration. Do we remember this? Yes or no? So, pure rotation is just same as pure translation, but there the body was moving like this. Now the body is moving or rotating like this. Do we understand this? Okay. So, they have the same angular velocity, same angular acceleration and same angular displacement, but the radius of circular motion are different. Radius of this circular motion are different. See, if you see this point P, it is moving on a different radius. If I take any point, let us say Q, this point Q will also move in the circular path, but the radius would be different. This point S will also move on the circular path, but its radius would be different. So radius are different. Do we understand this? Radius are different. Now, since radius are different, and I'm going to write it to the top. Radius are different, therefore the velocity and accelerations are different. The distance traveled by them is also different. Do we understand this? The particle which is moving in a larger radius farther away, he moves a large distance compared to the particle which is nearer. Do we understand this? So their distances that they're traveling are different, their velocities are different, their accelerations are different, but their angular velocity, angular displacement, angular accelerations are same. Why their distances are different? Because their radiuses are different. All particles are moving in circular path, but different radius. Different radius. Do we understand this? Particles on the axis, do they move at all? Particle which lie on the axis. And as you can see, this is the axis. You can see the axis, yes or no? Particles on the axis, they are not moving at all. They just particles on axis are at rest. So if you have such type of motion of a body, then that motion of the body would be known as pure rotation. And as you can see, pure rotation just looks like, just feels like it's a pure, it's a circular motion. Do we understand this? So we have done pure translation also. F is equal to ma whenever we applied, that was pure translation. We have done pure rotation also. Wherever you write, wherever we have done question of omega and alpha, the same are the question for pure rotation. Nothing has changed. Everything remains same. Do we understand this? So these two we have done. The only thing we have to do is the third one, which is the most difficult one. Anyways, do we understand pure rotation? Now I'll give you time to write all these points. Once you have understood this, now you write them in your language. And I'll give you time. Don't worry, I have time. So this is pure rotation. And as you can see, pure rotation has got a lot of things to do with circular motion. So we'll go back to circular motion and see some things. But let us just finish the third type of motion. And the third type of motion would be a combination of translation and rotation. So you can write it the third type of motion, combined motion, combined translation and rotation, combined motion. Now, before even getting into that, can anyone give me an example of a combined motion where the body is rotating as well as translating? Anyone knows the example of a combined motion and you see in day-to-day life? Yes? No one knows the answer. Huh? We see it in everyday life. Someone give an example of revolution of Earth around the sun. It is not pure rotation. It is a combined motion because the Earth is rotating like this. Gar 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 gar. This is Earth. Earth is rotating like this. Gar 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 gar. But it's also moving like this. Par 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 par. So this is combined motion, translation as well as rotation. Any motion that you see in your day-to-day life is just a combination of this. How does the wheel or tire of a car move? The tire rotates, gar 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 gar, but it also moves forward, par 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 gar 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 par par par. Combined motion, rotating as well as translating. The cycle, the tire of your cycle, gar 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 and par 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 par. Combined motion, combined translation and rotation. This is a pen. If I throw it, it goes like this. It goes like this, dhar 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 dhar, but it's also going par 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 par. This is also a combined motion. Combination of translation and rotation. If I throw any ball, you take any cricket ball and throw it. That is combined motion. The ball is spinning, thar 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 thar. It's also going gar 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 gar. So combined motion. So what is the combined motion? That is the combined motion. In this, the body rotates. It's in rotation, but it also moves forward. It does not rotate at one place. Do we understand this? It does not rotate at one place. Fan is rotating at one place, but God forbid if this fan falls while it is rotating, that is combined motion because then it will be rotating as well as falling down, and that will create a big mess here. Let's not get so messy and try to understand what this combined motion is. Do we understand this? Yes or no? Huh? You have 2 minutes to
Sir.
note it down. Note it down now. So we have seen the differences between all these motion, pure translation, pure rotation, and translation plus motion. I'll see you in the next class. Take care. Bye bye.